And I will give a short introduction and a short overview. Those who have been here before at the last info sessions know it already. And then I will hand over to Hussein to present ICPAC to us a bit more. So my name is Caroline Eichler. For those who don't know me, I'm the Partnership Management and Training Specialist for SEWA. SEWA is Strengthening Early Warning in Africa, and I will also give you a short overview briefly about ECMWF, the European Center for Medium Range Weather Forecasts. We are an intergovernmental organization. We have our 50 years anniversary this year, and we are an operational service as well as a research institution providing medium range forecasts as well as sub-seasonal to seasonal forecasts, reanalysis, and we are trying to make those better every day for the benefit of our members. We are also an interested entity for the European Union, and in that regard, we are operating 2 Copernicus services as well as Destination Earth. The Copernicus services are the Climate Change Service and the Atmosphere Monitoring Service, and we also support the Copernicus Emergency Management Service. Recently, we started on a new endeavor called Strengthening Early Warning in Africa, or SEWA, which is funded under the Global Gateway Initiative by the European Union as well. And we are very pleased that we started it. However, it is not our first engagement with Africa. We have already a long-standing support to Africa, in particular through either cooperation agreements or WMO programs, like, for instance, SOF, which we are supporting very much. And as you can see at the end of this timeline, it's the Strengthening Early Warning in Africa, which just started on the 1st of January this year. So within SEWA, we support the UN Early Warning for All initiative, as well as the African Union Commission's Africa Multi-Hazard Early Warning and Action System, or AMUVAS. And we also try to build upon existing capabilities, initiatives, but also tools and systems and data that's already there. So we really try to find the gaps to build on it and to try to close those gaps. SEWA is implemented together with the African Union Commission as well as UMITSAT, and it's structured around 5 outputs. We are the main lead for output 2.3, which is called Enable Co-Design and Delivery of Impact-Based Forecast Services and Tools. And just to give you a brief overview what this implies. So we'll issue a couple of calls within SEWA, and the first one was actually not a call, but it was an ITT, and the rest will be grants that will be issued. And the first one is the scoping study is already underway. It is there to assess the current landscape of early warning and impact-based forecast initiatives across Africa, but it also assesses the tools used, the systems used, the data used. So many of these things. It also assesses with initiatives out there and what I learned of the initiatives been done already. And we are working together with a consortium of 4 different entities, from HKV, a Dutch company, as well as Deltares and the Netherlands Red Cross, as well as TAMO, who are based in Kenya. So this scoping study will then provide us with hopefully many insights about gaps and tools needed. And another thing that will add to this knowledge base is a call for expression of interest. And this call will assess the interest that is there of our partners who are interested in implementing this project together with African entities, and what capabilities they bring to the table as well. And then we'll launch likely next year in Q2 4 grants on 4 regional pilot projects on impact-based forecast services and tools, and those will be done together with the regional climate centers. I will tell you a bit more on the next. And those regional pilots will also be supported later on by a grant on training and capacity building, and also a grant on digital tools that focuses on artificial intelligence as well as machine learning, and how this could also support the implementation of those pilot projects. So as said before, we try to connect the European and the African communities. And how do we do it? And how do we foster innovation and knowledge transfer? We rely on institutions that have been there for a long time and have a lot of knowledge already. And those are, in our case, the regional climate centers. And within SEWA, they will act as a regional coordinator. They will help define needs and user requirements. They are the prime focal point also for the partnership at a regional level, but also at an African level. They will engage with stakeholder users in the regions like the RSMCs, so the regional specialized meteorological centers, as well as the Met services in their region. They will, of course, advise and provide inputs to early warning. So that also means which tools are needed or which tools are there, and they will also help on the demonstrators that will be developed. They bring the community together. They, of course, benefit from trainings and pass this knowledge on, as quite often they are training centers as well. They also will help to design training materials or support in the training organization or host trainings themselves. And in that regard, they, of course, also support the knowledge transfer and outreach. So how does it look like? As said before, we'll have 4 grants, and those 4 grants are in Western Africa, Central Africa, Eastern Africa, and Southern Africa. And the Southern African grant also includes the Indian Ocean Islands, and we'll have a regional climate center for each of those grants. And we also have ICPAC, who is responsible for the coordination within or across the grants and also on the continental level. And today we have ICPAC with us, who will be included in the grant on Eastern Africa. And so, as said before, the RCCs will be part of the call for grants. That means they have to be taken on board for a minimum amount, at least as a regional coordinator. However, they can, of course, do more tasks and be part of a consortium as well. And this is one reason amongst many why we have these info sessions, but we also want to share what RCCs are doing, what they're capable of, and their mission, vision, and who are their members and so on. And this is why I'm really pleased that Hussein Said is with me. Bas is presenting ICPAC to all of us. Hussein, over to you.
Thank you very much. Let me share my presentation. Can you see it?
Yes.
Okay, great. So again, my name is Hussein Said. I'm currently the acting head of climate diagnostics and the prediction unit at ICPAC. So I'll be presenting about ICPAC and what we do generally. So this is the outline of my presentation. I'll briefly talk about why climate service matter for the East African resilience. It's just a very brief one slide. And I will talk briefly about the ICPAC and also our mandate, membership, and also the key products and services that we develop and disseminate to the users, including the data sets and also the methods that we are using. I will talk about the youth platforms that regional and also sub-regional levels, digital platforms that we developed to disseminate some of this climate information and products. I'll also talk briefly on the ongoing initiatives that we have, particularly related to this impact-based forecastings. I will highlight the gaps and the challenges that we have, and also the key priorities and also our expectation under the SEWA projects, and also some of the opportunities, particularly with this ongoing initiatives, to have that synergy and also scale up some of the pilots that we have done in the past. So this is all, those are the things that I will be talking about. Briefly, why climate service matter for East African resilience. So the East Africa is one of the most vulnerable regions to the climate extremes. So the frequency and the intensity of the climate extremes has been increasing in the last few decades. What you see at the bottom is a snapshot of what was happening in the last 15 years. So you can see in around 2019 and 2011, there was a severe drought, which led to widespread famine over most parts of the Eastern Africa region. And this drought in Somalia alone, which led to the deaths of about 250,000 people. And over the three countries, Ethiopia, Kenya, Somalia, and several peoples, more than I think 13 million people, according to the analysts and reporters, have been food insecure in IPC phase 3. Number of livestock died, and after that there was a strong event. Again, this has implication again in the different parts of the region. For the northern part of the Eastern Africa, which led to the extreme drought again mostly over Ethiopia, Sudan, and South Sudan. But for the southern part, which led to the wet conditions. Then later on, there was this tropical number of tropical cyclone happened in the nearby oceans around 2018, 2019. Again, that one led to this heavy rainfall and flooding over most parts of the region. And because of those heavy rainfall and due to the tropical cyclone, also the strong Indian Ocean dipole, then the region experienced that the worst ever desert locust, which happened after several years. Then around 2020 and 2022, again, there was a prolonged drought, 5 below averaged rainfall season. And this one again led to deaths of again livestock and also to everything this time because of this expansion of this early warning information. There was no famine, there was no people haven't died, but the impact was huge in terms of the socio-economic impact and also the deaths of livestock. In the three countries, Ethiopia, Somalia, and Kenya, over 13 million livestock died because of this the drought. Then after that, the region experienced again heavy rainfall, which led to flooding and also destruction of properties. And also disease outbreak. So, but what I would like to highlight is the region is just going like from one phase of this climate extreme to the others, and the number of these normal years becoming very rare in the last few decades. So really this climate information, particularly this tailored climate products and services, and this impact-based forecasting is very critical for decision-making in the region. About ICPAC, so ICPAC stands for the IGAD Climate Prediction and Application Center. IGAD is one of the regional economic blocks of the African Union, and ICPAC is a specialized institution of IGAD. So ICPAC, or the Drought Monitoring Center, before established in 1989. This was because of this drought in 1970s and 80s. One was established in Nairobi, and the other one was established in Harare in Zimbabwe. Then later on, a protocol was signed by the member states, and the name changed, and it became the IGAD Climate Prediction and Application Center. That was in 2012. And then 2017, we have passed the demonstration phase and meet the criteria to be designated by WMO, and we became a WMO designated regional climate center in 2017. In 2021, we got that observer status for the United Nations framework on climate change. So we participate in COPs and also contribute, support member states on the adaptation and mitigation issues. In 2022, we become a member of this AUNIPAD, which is the network of water centers of excellence. Then again, in 2023, we become a member of my climate risk regional hub. So our vision is to be awarded class center of excellence in climate services for sustainable development in the Greater Horn of Africa region. And the mission is to foster climate service and knowledge to enhance community resilience for prosperity in the Greater Horn of Africa region. In terms of this area coverage, so we are covering 11 countries, 8 IGAD member countries plus 3 non-IGAD. So the 8 IGAD member countries are the ones highlighted in gray, and the light orange colors are the 3 non-IGAD member countries, but part of ICPAC. So we are serving over 300 million people from these 11 countries. And we closely work with the national institutions, particularly the National Med Services, the sector ministries, the humanitarian agencies, UN agencies, the academic institution, universities, and also development partners. So particularly the National Med Service are our primary users of this regional product. Of course, we also work closely with the sector ministries such as the Ministry of Agriculture, Ministry of Water, Health, Disaster Risk Management institutions. In terms of what we do, the key service areas, so those are just the key ones. One of the key areas is the climate monitoring and forecasting, which is really the core functions of ICPAC. So we produce climate for different time scale in future. I will come to this one later on. Climate conditions on different again times weekly on my decadal 10 days. Also on one of the application area is agriculture and food security sector. We monitor the food security situation in the region and develop this outlook of the food security and also what happened in the past in collaboration with the other UN agencies. We have the disaster risk management unit also, which deals with the understanding of the disaster risk knowledge in the region and also the anticipatory action. We work on the water resource, predicting the availability of water resources in the region based on the seasonal forecast and also flash flood forecasting. I will come to those one later. And also we do this environmental monitoring using the geospatial and GIS technologies. So we monitor the rangeland conditions, the cropland conditions, and also this the patterns of this land use in the region. Co-production is one of the key service areas. We closely work with the users from the different socioeconomic sector in the region. On longer time scale, climate change. So on this is also one of the key areas, and a new unit has been established at ICPAC to deal with this long-term climate change projections and also the adaptation and capacity. This is also one of the core functions of ICPAC, and this is cross-cutting in the area of this climate data monitoring, forecasting, and also sectoral applications. Just to talk a little bit about the different forecasting or predictions methods. Apologies. the forecasting and prediction methods that we use in ICPAC. So we use two this downscaling methods. One is the dynamical downscaling, and the other one is the statistical downscaling. The dynamical downscaling is based on the weather research and forecasting, and we run the WRF model at ICPAC on regular basis and produce different products. And the statistical downscaling technique is mainly for a longer timescale climate information, the subseasonal to seasonal forecasting. So for this one, we use again different calibration methods such as linear regression, logistic regression, and also the chemical correlation analysis. And then from there, now we form a consolidated forecast and produce the climate outlook, seasonal and also multi-seasonal climate outlooks. And some of the products are this, what you see on down. I'll come to those ones shortly. So the dynamical downscaling, as I mentioned, is based on the SEWA model, and we downscale the CFSB to a global forecast, which is available on 38 kilometer resolution. This forecast is available online on 6-hourly interval. So we produce forecast for the next 7 days at 10 kilometer resolution. And what you see on the right is the outer and the inner domain that we are using to produce those climate forecast products. So this forecast, the weekly one, is on 10 kilometer resolution, and the output is available hourly to daily time scale, and we use those for different applications and produce different products. So it's not only for ICPAC, also the National Met Services have access also to the ICPAC computing facility. They have access to the ICPAC tools and also some of the data sets, so they can generate these products also at national and subnational levels. So based on the WRF, we produce this tailored products. So one of the key product is the track of this tropical cyclone. We don't run this one on a regular basis, but this is when tropical cyclones start developing over the nearby ocean. We start simulating and provide that track of the tropical cyclone, the prediction. The other key product is this exceptional rainfall forecast, showing this areas expected to receive this heavy, very heavy, and extremely heavy rainfall based on this the percentile, the 90s, 95s, and also the 99th percentile. The other key product is the heat, extreme heat. Again, we provide on areas expected to receive this extreme heat, and particularly this heat is becoming an emerging issue, particularly these areas over the northern, which never experienced this, currently they are even closing schools and other also institutions because of this extreme heat. So they will not be able to operate those areas. Particularly this particularly over South Sudan. We have observed this in the last couple of years. Again, we have the anomalies and also the total, and those on weekly time scale. On seasonal, so ICPAC is the first RSC to implement this objective seasonal forecasting technique as per the recommendation of this WMO. So WMO recommended the Regional Climate Center and also the National Met Services to produce or to use an objective forecasting methods and produce products and forecast products that are traceable, reproducible, and verifiable. So ICPAC is one of the first, if not the first, to implement this one. We started implementing it in May 2019. And since then, we are producing our products using this objective forecasting technique. So all the data sets, the models, the calibration methods, and the other things have been documented since then. And we verify also the forecasters at the end of the season. So the calibration, as I mentioned earlier, is then like three methods, and each method has its own pros and cons. So this is a handicast of the model, and also the observed rainfall at each grid point and develop products. And the other is the canonical correlation analysis, which many national Met Service and regional climate centers use based on this climate predictability tool, by identifying this optimal correlation between the GCM predicted and observed rainfall. And we also implemented this objective, the logistic regression approach. This is again by finding the relationship between the rainfall over East Africa and also this large scale system over the tropical oceans, such as the INSO, the IOD, and also the SST in the tropical oceans. Then finally, we produce or calibrate the forecasts from the different global prediction system and form the consolidated forecast, which we call it objective consolidated forecast. Just to show it in map, so we used like different global prediction models. This is like we access the raw data from the portal and also from the IRI data library. And we calibrate those forecasts for individual models using the different calibration methods that I have mentioned. Then from there, now we form this multimodal average forecast. So we'll have the average from the first technique, the second technique, and third technique, and later on we consolidate it. So some of the key products on the seasonal time scale, one is the terrestrial forecast, which is the key product, the rainfall terrestrial forecast and the temperature produced objectively. And we also produce this tailored products, sector tailored products, such as the probability of exceeding a certain threshold. This is important for agriculture sector particularly. What is the probability of seasonal rainfall exceeding 300 or 400 or 500 millimeter rainfall, depending on the season and the area. We also produce the intra-seasonal rainfall characteristics, such as the start of the rainfall season, the expected onset date, and also what will be the probability of an early or late onset, and also what are the maximum dry spells that we are expecting with that particular season, what are the maximum wet spells that we are expecting within that particular season, and also the expected start date of those maximum and also minimum, the maximum wet spell and also the maximum dry spell, the expected dates of those. So these are like tailored products for particularly for agriculture and food security sectors, and these were developed based on the feedback that we received from the users. Currently, we are working on the sub-seasonal forecast, and we produce, currently we are using the two prediction system. It was really wonderful. The forecast data was not available in real time before, but CMWF recently made freely available. So we are calibrating those forecast. One is the JEF NOAA and also the ECMWF. So currently we are producing those prototype sub-seasonal products and looking at the skill in the region, and we are planning to operationalize it in the next few weeks. It will be publicly available. So this sub-seasonal forecast, it fills the gap between that, the weekly and also the monthly. So it provides information on the dry or the wet condition for the next 4 or 5 weeks within that particular month. And this is very useful information for tactical decision making, particularly for agriculture and food security sector. Then on longer time scale, we produce climate change products and information. For this one, we don't run any climate change simulations. What we do is we access the global and also the regional projections. We analyze those projections for the region, and also we downscale or bias correct those projections for different applications. So these are just some of the product and the different also, based on the Cordex projection, based on CMIP 5, CMIP 6. We produce this climate change information, and some of the products are also available from this link that I have provided below. So our goal is really to provide that seamless early warning information from this short range to a longer time scale. So on hourly and daily, we have the WRF model, and on to the weekly, we have the WRF. Monthly and also seasonal, they are using this global the seasonal prediction forecast, and we calibrate them for the region. On longer term, we are producing this long-term climate change information, but there was a gap on this sub-seasonal time scale, which feels between this weekly and monthly. We are currently working. The other was on this decadal prediction, which fills between this seasonal and also the long-term climate change projection. So on sub-seasonal time scale, we are working on it, but the decadal one, we haven't started. The other key area is, so those was, what I have discussed before was about the forecasting. On the other key area is the data service. So that is also one of the key or the mandatory function of Regional Climate Center. So we receive station data from the member states, and we produce a regional grade data sets by combining the station that we are receiving with satellite data. And we use those data sets to monitor the climate condition and also calibrate our forecasts. We also support the member states in data management, grading, and also monitoring of this analysis, and also monitoring using this different tools that we have in ICPAC. We have signed a data sharing protocol with the IGAD member countries a year ago through the support of this CLIMSA. So in the past, we used to receive data on decadal or 10 days basis, but we're not able to access the daily data from the member states. And the other issue was also the number of stations that we were receiving was quite few. So they have agreed to increase the number of stations and also share the daily data. So they have started sharing data, and also some of the countries have started increasing the station data sets that they are sharing with ICPAC. The other one was on this data is the RARS antenna. This was supported through the EU-funded SAWIDRA program, and one was installed here at ICPAC. And the objective of this one was really the purpose of this one was to track this and receive this polar orbiting satellite meteorological satellite data, and to enhance this real-time numerical weather prediction. So the whole objective was to improve the forecast through data simulation by receiving these data sets. But this was installed. We have been receiving the data. Unfortunately, we didn't operationalize it because of some challenge. There was no training or capacity building after the installations. So the data format, everything was a bit challenging. And currently, there's, I think, some issues with the software upgrade and so on. But it is one of the areas supported through the SEWA project or program. with the support of the UMETSAT under the UMETSAT component. So one of the area is to upgrade and also maintain the RAR station. Yeah, this one I have already mentioned. So one of the other area is also on crop and rangeland monitoring, forest monitoring, and also pests. So we have been doing this one through this satellite data and also use of this climate forecast data that we are producing. We have been tracking the location of the desert locusts in the region when there was invasion, and also we were able to also provide that the track of locusts based on the climate forecast information. The other key area is the user engagement platforms. So one of the platforms that we have at regional level is the Greater Horn of Africa Climate Outlook Forum, which some of you might have participated or heard about it. So it is the backbone of the co-produced user-driven. So we organize GACO 3 times a year for 3 main rainfall season, and we this gap of bring together the decision makers, the stakeholders, the researchers, and also producers of the climate information, the media, to develop the regional climate outlook and develop advisories and mitigation strategies based on that seasonal climate outlook. So it's not only development of the advisories, but it is also a platform to co-design and co-develop this the climate information based on the user feedback. So it enhances the interactions and also the user feedback, and also to share the best practices and outreach. So what you see on the right is just some of the photos. So socioeconomic sectors from the different countries participating in GACOF. So once we release the seasonal climate outlook, then they sit together and then they assess the implication of that seasonal climate outlook and develop advisories and mitigation strategies for the different sectors and also for the different countries in the region. So here is it's just a photo of the DRM, the conflict working group, the livestock, the water, the agriculture, and also media. And media, we have started engaging them recently, and they play a significant role, particularly for disseminating and communicating this climate information. We also do sub-regional climate outlook forums. These forums are for the cross-border areas, particularly there are cross-border areas identified by IGAD, cross-border area of Kenya, Ethiopia, Somalia, and Ethiopia, and also Sudan, Ethiopia, and so on. This one, we don't do it on a regular basis like a GACOF, but when there is project and support, that's where we do it. And we have been doing this one for the last couple of years. And there's one we're planning to do next year in February for March to May rainfall season for those cross-border areas of Ethiopia, Somalia, and Kenya. Yeah, so the aim of the cross-border area, the aim of the cross-border or sub-regional climate outlook forum is to enhance the uptake of the early warning information, but by the communities and the last miles. We engage the users directly when we do this, and those information also will not be very technical like the GACOF. The advisories will be translated in local language so that they can be easily understood and consumed by the last miles. Yeah, so when you look at the flow of the information, so at regional level, we have this Greater Horn of Africa Climate Outlook Forum, and of course, we do also the sub-regional one. Then the national institution, they conduct the National Climate Outlook Forum. Then at sub-national level, we have the PSCB participatory scenario planning. Then at community level, particularly for agriculture sector, we have this PIXA, and so at national level, it was the responsibility of each country, but ICPAC, when it gets support from different programs and projects, we support them. And we also demonstrate the use of this climate information at community level. And we have done it with a couple of projects and programs in the past. One, we have done it through CLIMSA program. We have done it one for Machakos and one for Kiboga, Uganda, to really demonstrate that use of this climate information by the last mile and also the communities. And when you do this, the PIXA and PSB, we do it in collaboration with the national institution, particularly the National Med Service. The other key area is capacity development. This one is cross-cutting. So we do training and capacity development for different thematic areas in data, in forecasting, modeling, also in the different applications in water resource modeling, and also in DRM, in agriculture, food security, and of course in the area of co-production. So these are some of the photos. So the capacity development that we do is not limited to the producers of the climate information, but also to the users of the climate information. The other area is this multi-hazard early warning system, the digital platforms. So we have a number of the digital platforms that has been developed at ICPAC in collaboration with the European and other international partners. One of the platforms we have is the East Africa Hazard Watch, which is a very important tool for monitoring and also visualizing this climate information, so it's accessible to the users for different hazards and also other products and information apart from the climate. So the climate forecast products that we produce on weekly and also the monthly and seasonal has been integrated there. So that is one of the tools that we use also to disseminate this climate information, but we have also other specialized tools, the East Africa Drought Watch, and also the East Africa Agricultural Watch, which we use to monitor drought conditions and also cropland and rangeland conditions. These two tools were developed in collaboration with the European Joint Center. Forest Watch, we are working on this one, Flood Watch, Pest Watch, based on the different climate information. So these are the different digital tools that we have at ICPAC. And here is just a snapshot of the East Africa Hazard Watch. So the users, they can select the climate variable they are interested in on weekly, monthly, or seasonal, and see, for example, the areas expected to receive those extremely heavy rainfall for that particular week. This is the agricultural watch platform for monitoring those rangeland conditions. The drought watch to monitor drought conditions, and also the flood watch areas expected to experience those floods. So we have this the multi-hazard warning situation room. So it's one of the 6 situation rooms in Africa, together with the African NEN and also ACMAD, Agreement, SADC. So we use this situation room to really monitor this different hazards. The other area, I don't know how I'm doing well time-wise, but I'll finalize maybe about 5-6 slides, I think. The other is the impact-based forecasting, which I think the focus of this session is, and I will be highlighting mainly on the current status and also the initiatives or projects that we have, just for your information. So there's a huge, big interest really from the users to have this impact-based forecast. So the impact-based forecasting is to go beyond this hazard prediction. So moving from what the weather will be to what the weather will do. And this requires also working together with the different institutions. So it's not only like the climate information, you need to have this the impact information, the vulnerability, and so on. So it requires that collaboration and partnership with the different institutions to get particularly those impact and socioeconomic data sets. So one of the initiatives that we have in ICPAC is this the IBF for agriculture sector, and this is funded by the Gates Foundation and is a pilot. So it's not sub-regional, but it's focusing on the two counties in Kenya, Machakos and Makueni counties. And the goal is really to develop the tool and see the products for to develop tools for those two counties first. Development of the tool for developing the agricultural advisories. So the first thing, we had a number of engagement with the stakeholders from the two counties. So the first thing was really to identify the key climate variables that are relevant for the sector and also for that particular region, and also the different socioeconomic indicators. This was also done through the engagement with the different stakeholders in the region, the poverty level, the available extension services. Do they use fertilizer seeds, the gender information? Yeah, so once we have the socioeconomic data and also the climate information, such as the drought indicators or the heavy rainfall, and also soil moisture and so on. Combine these ones and predict the availability of the crop yield for those particular areas. So the ultimate objective is really to produce that the expected crop yield for the two counties, combining the climate, the exposure, and also the vulnerability information. And this is being done using machine learning. The other is the development of thresholds and triggers. This was another also pilot done in collaboration with the WFP for Uganda, Karamoja area, and also Burundi. So what we have done is, so we need to go beyond this tercile forecast. So what we have done is we engage the stakeholders. We looked at the past drought events and also the impacts and what were the thresholds based on the rainfall or the soil moisture, those thresholds in the past. And from there now, once we identify, so the thresholds were identified based on the standardized precipitation index values. And now, based on the prediction, we need to identify what is the probability of getting those thresholds for the different drought categories: moderate, severe, and also extreme drought. Yeah, there's also another initiatives focusing on hazard modeling, impact estimation, and also climate storyline. This one is still ongoing. And the objective is the main one is objective of this one is really to develop climate storylines for an event catalog on drought or flood disasters in the region, using this different ensemble prediction systems. This is also ongoing. I hope our experts joined here. You'll give us more information if there are any further question on that. The other is on the AI-driven forecasting. This is also is a project being implemented in partnership with WFP, University of Oxford, and ECMWF. The project is called Strengthening Early Warning System for Anticipatory Action. It is called SEWA, but with double A. Yeah, so the whole objective of this one is to improve the weather forecast using this machine learning techniques and also build the capacity of the national met services. So there's a machine learning method tool that has been developed by University of Oxford. So we are using the ECMWF dynamical forecast to post-process come up with an improved forecast for the region, and is being implemented currently at country level. Well, we have some, but the focus is mainly for Ethiopia, Kenya, and currently Uganda, and these are some of the products. The other also tools that we are trying to use and also develop this impact-related climate information is the WRF Hydro. This has been installed and operational at ICPAC. So we have the weather research forecasting model that we use using the CFS forcing data, but WRF has like those different also specialized systems. The WRF crop to produce crop related information, and also the WRF hydro to produce this flash flood and also other relevant information for that particular sector. And so we have a team also working on this one. On gaps and priorities and opportunities. So these are some of the gaps that we have and also the challenge, particularly in really to develop this impact-based forecast. One is the limited availability of ground-based observation and also uneven spatial coverage. You have seen the spatial distribution of the station data that we are receiving. So you'll find some areas, a huge gap. Again, the number of stations that if we are receiving are not really adequate to produce those improved climate information. The other is limitation data assimilation and also the lack of standardization in the data collection, and also to have that consolidated repository for impact and socioeconomic data. This is again very key for impact-based forecasting. So I think that impact and socioeconomic data is very critical. We are working on that one already to get and have those data sets in one repository, but still there's that gap. And also, we have that limited capacity for implementing this impact-based forecast. So what we have so far is mainly on pilot basis. So still there's that limited capacity, and also the inadequate computing infrastructure, particularly systems with GPU, especially to use this machine learning techniques. This GPU infrastructure is very critical. What we have is a CPU infrastructure. So what do we expect from the SEWA? So one is really to improve the access to Copernicus and also the ECMWF, those high resolution data sets, and also to also build our capacity on the development of this impact forecast. Of course, that is the main objectives. Particularly developing is really some kind of operational products that can be used by our stakeholders and users. Strengthening ICPAC's capacity in data integration, in IBF forecasting and visualization, and also the access to cloud computing environment to process this impact-based forecast, and also this apply machine learning tools. And the key, of course, that we are really looking forward is to enhance also our collaboration with the European institutions, particularly the European National Meteorological Hydrological Services. There are lots that we want to learn from them. Well, if there's also an opportunity you would like to really implement this, the ECMWF's machine learning, the IFS model, and produce products at regional level. Yeah, so opportunities are really just to mention. I think there is some work ongoing, as I have highlighted in the previous slides. So I think if we align the IBF with the ongoing and also the planned IBF initiatives, of course, there's also one project that we will be starting probably around middle of next year, which also has a component of the impact-based forecasting. And yeah, so like to really have that synergy with this one to avoid duplication and also maximize the impact. And also the especially for the stakeholder engagement, we have this co-production platforms that I mentioned, the regional one, the GACOF, PUCOF. So I think those are really key platforms for co-production, the validation, and also the continuous refinement, improvement of this tailored and user-driven impact-based services. So there's that opportunity, since we will be holding this the GACOF every year, 3 times a year. So there's that, and having different the different stakeholders in that platform is a good opportunity, especially if for assessing the needs and also for validating those products and tools. Also later on, there's also an opportunity to integrate those SEWA products to the digital platforms that we have in ICPAC, the East Africa Hazard Watch, or the Drought Watch, or this Watch. Yeah. We need to also look SEWA as a catalyst really for long-term sustainability. And also this institutional ownership. So we want to operationalize the products and tools that will be developed under SEWA. So that's synergy and the partnership is very critical for that one. That's all I have. Thank you very much. I didn't go beyond the time I was given. Thank you.
No, all good. You're actually perfectly on time, I think. Thank you. Thank you so much, Hussein. Are there any questions? Umberto had a question in the chat. I don't know if you can see it. If not, I can read it, or he's still here. He can also.
Yeah, I'm here. I mean, I think you probably answered in some way in one of the slides later on, but it's just really to understand better. My understanding is that at the moment you're not doing any data assimilation.
Yes.
Okay. Yeah. And that is one of the challenges you mentioned in one of the last slides. Okay. And,
yes.
and that is the case for all sorts of observations, you know? So both in situ, satellite, so no data assimilation at all.
Yeah, no.
And do you do well, you said you do some statistical sort of downscaling, but do you do any post-processing, let's say, of the WRF output to take into account the observations that you have available? Or no?
For the WRF output, we are not doing any calibration. So the WRF forecast that we have is just for 1 week, for the next 1 week. What we do, the calibrations that we do is for sub-seasonal and also the monthly and seasonal forecasts.
Okay.
So for that one, we use this different statistical calibration methods, the canonical correlation analysis and all.
Yes. Yeah. Okay. Thank you. Okay. Thanks.
Great. Thank you so much. Are there other questions? Oh, we have a thank you from Claudia. Thank you very much. I pass it on to Hussein right away. You can read that probably yourself. If there are no other questions, then there's Sandra.
Hello. Sorry, this is not a question regarding this presentation. Thank you Hussein said. It was very interesting. Well, I'm Sandra Silva from the Portuguese Institute for the Sea and Atmosphere. And just a question for you, Caroline. I don't know if you have the answer. This because one of my colleagues have been this week in Geneva, and she said it was approved recently, this week, the new regulation for the early warning for all. And I don't know if you have information that you can bring us in what way this will impact in this program. Or will benefit or be, because I don't know. If you don't have the answer now, it doesn't matter. We can then discuss in the next webinars. I also will ask my colleague for more information to understand better what this relation, but I don't know if you can bring us any information regarding this.
Sure, I can try at least. So the regulations that have been approved by WMO this week, they support the early warning for all initiative. So WMO is mainly, they do many things, but one of the biggest or most important thing they do is they set standards. And this is why they have these regulations. And with this, they now have a regulation on how early warning should look like. It's quite, it's pretty basic, I would say, but it defines like a common set of things that should be fulfilled to issue a warning. So this is the part WMO had to do as a basis for early warnings for all. And now all WMO members have to implement it. And this is what basically UN early warnings for all, or in particular the pillar 2 of WMO, but the whole initiative is all about to enable members, and that means in states in that regard, to issue early warnings. But in our sense, in the WMO sense, those will be the Met services. And they now have basically a legally, it's not always the UN, so it is they all signed the convention. So they said that they will, all the things that are agreed upon at WMO, they will implement it on a national basis. But it's now up to the countries to implement that. Like for instance in Portugal, I'm sure you have an early warning system, but if you wouldn't have one, you're now from WMO side obliged to implement one and to work together. And this is about multi-hazard early warning systems, to work together with all the institutions in Portugal to set up this early warning system in Portugal. And SEWA, and we are there to support this process. So SEWA is there to enable Met services to issue warnings, and we try to work together with the regional climate centers, and we'll only have some pilots, so we won't be able to enable all the Met services in Africa to issue those. We'll hope we can have some pilots to enable at least some of the Met services, and those pilots could then be shared with other countries as well, or with other Met services. Is that helpful? Okay, so I'm also happy we can also have a bilateral discussion if that's helpful. Okay, any other questions? If not, then as usual, we're on the page where you registered, we'll also have some more, I think 3 more sessions with the other RCCs that were not presented yet, and I post the link again. You can register for those sessions, but also on that page you will find the presentations and the recordings of all of the sessions. So if you can also forward it to colleagues or watch it later again, whatever you need, or if you missed one, you can watch that again. Again, Hussein, thank you so much for your time and the presentation, and enjoy Reading next week. And then I wish you all a nice day. We're still early for most of us.
Thank you. Bye-bye.
Thank you very much.
Bye.
Thank you.
Bye.
Thank you.
Bye-bye.
Bye-bye.